Alrighty, hello everyone, and welcome to our very first Northeast Ohio AI Meetup in the Bounce Hub in Northeast Ohio / Akron area. Thank you everyone for coming. Today, we're going to be talking about the overview of AI. AI is a very broad term, as you're going to find out here, and so we're going to cover a lot of topics very fast. And I want you, while you guys are thinking about this presentation, to keep in mind of what it is that you guys are interested in, so that way in future talks, we can have more deep dive discussions on each of the topics individually. Also, the slides at the very end of it will be available online. And with that, I'm gonna get started. So, introduction. Hello there, my name is Kyle Vasulka. I'm a software engineer by trade, and by night I'm an AI, artificial intelligence paper reader. I go home and I find very, very fun AI papers to read about and implement, along with my friend Chandler here, who's in the front audience. We have met him
Hello.
today. And Chandler is also a software engineer by day. And at night, we both have a small company called Time Surge Labs that we love. Essentially, what we are is a way to turn all of our passion towards artificial intelligence into something useful. So we do stuff like artificial intelligence education, some software development, some consulting, some hosting. We also have a bunch of AI products that we have. A lot of them are open source and on our GitHub. So would recommend checking that out. It's very fun. What are we talking about today? So today, here's our table of contents. We have a definition of terms, because like I said, AI is a very broad area of study. We'll also have the state of AI, as in what are the recent advancements in the past month, or maybe even several months since this is our first meeting. How to use AI on a practical level, like how can you use it in your personal life, how can you use it in your work, as well as a couple of discovery features where we're going to try to showcase some of the really, really cool tools that Chandler and I have found, and I've heard a bunch of other people also say that they enjoy, and there are so many, and I'd also love for any of the ones that we miss, you guys to tell us, and for us to all talk about it. It's going to be cool. And lastly, doing a small dive into how AI works under the hood, and some of you guys may even know like way more in depth about Chandler than I do. So let's get started. So firstly, I have a couple questions for everyone. Raise of hands. How many people know what ChatGPT is? 100%, 99%, question mark, that's great. How many of you guys have used ChatGPT or an equivalent like, awesome. How many of you guys know what an API is? Perfect. And how many of you guys know like in-depth machine learning terms, for example, learning rates, epochs, vector databases, convolutional neural networks, recurrent neural networks, and LSTM? There's so many different ones, attention. There's too many to list here even. So, all right, 4 more questions. So sorry, getting them all in the front here. Have any of you guys used the AI features that exist inside of social media? For example, like Facebook, question mark? It turns out like if you go to do a post now, when you write your post, there's like literally a button that you can, instead of going to ChatGPT and typing out your post, you can put it on inside of, they have it inside their UI, which is kind of neat. They also have it integrated into Notion, Google Docs, Gmail, Canva. Any of you guys use those? Raise your hands, question mark. Awesome, awesome. How many of you guys have used GitHub Copilot or like have generated AI art before? Aha, very cool. Do any of you guys integrate AI into products that you guys like have as part of your company or in any products that you primarily develop on? Very cool, very cool. Welcome, welcome. Come and grab a seat. And the last question for this slide, at least, is actually, I think that's the last one. Huzzah! All right, so definition of terms. So what is artificial intelligence? Artificial intelligence is a very, very broad term, covers many, many topics. So many, in fact, that it's hard to list them in a single slide. So today what I'm going to do is give a quick whirlwind of some of the different areas that exist, not an exhaustive list, and then we're going to double click into a particular one called generative AI. So you can see here that we have an artificial intelligence graph. Inside of that, we have machine learning. Subset of that is deep learning. Technically, a subset of that is generative AI. But also, most graphs that you see online kind of categorize the different areas of machine learning in different ways. So it's kind of interesting. On the bottom right here, we have one of my most favorite recurrent neural network training videos from this guy named Seth Bling online on YouTube. He basically programmed a recurrent neural network to play a platformer game, Super Mario, in order to beat a particular level. I thought it was so cool. So let's talk about a couple of other examples of artificial intelligence. We have image classification, or text classification as one of like the broader areas of artificial intelligence. The data set on the right is a very commonly used one, cited one for when you're learning how to create your own text classification algorithm, where you try to determine between, with a shallow neural network rather than a deep neural network. To my knowledge, a neural network is kind of defined as, a deep neural network is defined as a network that has more than 8 layers, more than 9 layers-ish, which kind of depends. But you instantiate your own neural network, and it turns out that you can determine something that traditionally was very hard for a computer to figure out, which is what number is on these pixels. It's very cool. Also, if any of you have seen Silicon Valley, there's a very fun hot dog, not hot dog meme that is very nice. And before was, when the show came out, I think was like a meme that it was very hard to do, but in today's world, very possible. Whole different area. We have segmentation. This guy right here is the segment anything model. This was made by Facebook. And essentially, it takes in a array of pixels or an image and also text. And so you can type out what text that you want it to segment. And in this case, it's segmenting a cat. And you can see it draws boxes around every single one of the cat elements, as well as the exact pixels as to what is cat and what is not cat. Very, very fun. Here's a small excerpt that Chandler and I built maybe 2 years ago before pre-GPT, where it was a very simple model, and I programmed it to see red, and it may have also targeted my hair, so that's kind of fun. So there's different levels of artificial intelligence. We have sentiment analysis. Is something is if given a piece of text or a blurb of text, is this very positive and fantastic, or is it neutral, or is it very negative? So there's a couple of different models on this website online called Hugging Face that I really, really enjoy and recommend, that has a plethora of machine learning models as well as resources on learning machine learning. We'll get to some tools later. But also, Chandler, my co-founder, made this kind of fun tool where he took a generative model like ChatGPT and fine-tuned it to perform sentiment analysis. But doing so is kind of like taking a semi-truck to the grocery store. Totally possible, totally works, but also it takes a lot of VRAM to run a large language model and for it to do that, but it worked. Very, very fun. We also have AlphaGo, AlphaZero, AlphaFold. A lot of reinforcement ones where you put a computer in a box and make it play a game to a set of rules against itself. And based on those rules, it gets better over time. And it turns out that depending on how quickly you can speed up the iterations and what algorithm that you use, that it can beat the world's grandmasters, both in chess, and when chess was considered this like prolific, wow, like a computer will never be able to beat a human at chess. And then it happened. And now we're like, oh yeah, computers can beat people at chess, but Go, that's like another level. Like there's way more action space, as they call it, in Go than there is in chess. And from the machine learning's perspective, machine learning engineers' perspective, they said challenge accepted, and then therefore made AlphaGo to then beat the Go grandmasters. And this has kind of been like a ongoing theme in the artificial intelligence community, where it's like, hey, I made this really cool tool and it can do this niche thing. And then people say, well, can it do this? And I go, no, not yet. Okay, so then they make a tool to do that thing, and another tool, and then another solution, another tool, another solution, another tool, another solution, until lo and behold, today's world, where there turns out there's like emergent phenomena that'll happen, but there's so many different structures. Here's the largest one that almost everyone online is talking about at the moment, which is generative AI. As we saw here, everyone raised their hand when they heard of ChatGPT or equivalent. And here we can see a ton of really, really cool images that are all artificially generated. You guys may be familiar with the large language models, being ChatGPT, number one, the first one that made it really, really popular. They released GPT-3, which was like a completions AI, and then after that, they made GPT 3.5 or ChatGPT, which is one that like caused it to really blow up and get like hundreds of millions of users in a single month. So crazy. Gemini is the one built by Google. That one's really cool because it's multimodal and can take up to like 1 million tokens in context, which we'll talk more about in a bit probably. And Lastly is Microsoft Copilot, which in my experience has been the one that most people seem to have the most familiarity with. For just talking to people on the street, Microsoft Copilot has been the one that it's actually the same thing as ChatGPT because Microsoft paid OpenAI when they first started like some ridiculous amount of money. I think on the order of $10 billion, question mark, but fact check me on that guy, to develop OpenAI with the expectation that the first X dollars of monetary value that it made, Microsoft would get. So kind of like what turned ChatGPT, which used to be this nonprofit entity, into this for-profit entity, which a lot of people are upset at OpenAI because they're named OpenAI, but they might not necessarily have all their code open or open source. So, but they definitely have made huge contributions because without the invention of GPT-2 and then publishing that paper, other chatbots wouldn't have come later. But that's also not quite a fair statement to say because Gemini, made by Google, the Google AI Research Lab, made a bunch of foundational papers that made GPT-2 possible. So one of the really cool things that's kind of like happened in this industry is that there's a ton of different individual research laboratories, and they're all kind of like cross-collaborating loosely, if that makes sense. So very cool. We also have AI art generation. Here are two of the most popular tools to use. Midjourney, which interestingly is a Discord bot that you can just type into. It's a subscription service you pay for. You ask for an image. This one's depicting an image depicting different types of artificial intelligence. So that's maybe kind of neat. You have DALL-E 3, which is just built in the ChatGPT API. The third option, which is not on this list, is Stable Diffusion, but you have to kind of like run that one locally or use like kind of external tools to use it. So even though that I only like showcase these two tools, these are like the directly used tools. There's going to be a bajillion other tools that you guys will see that most of them go off of the open source option, which for AI art generation is Stable Diffusion. Speaking of those options, we have a bunch of different Stable Diffusion flavors. So because Stable Diffusion being the open source model, all of you guys right now could take out your laptops and go to Hugging Face and clone it down to your laptop and run it locally. There's a bunch of companies that do that for you on your behalf. So a lot of these, for example, here we have Artflow AI, Civet AI, OpenArt, Leonardo AI. I heard of another one yesterday that one of my friends utilized. Oh, the name was on me. Oh, anyways.
Dreamlike Art.
Yeah. So
yeah.
What was it?
Dreamlike Art.
Dreamlike Art. Yeah. So there's just so many and they pop up every day. And a lot of these will do, they take the Stable Diffusion technology and they'll add a couple layers on top of it. So that way features that exist on one might not exist on another because everyone's like building atop that open source like foundation that's being provided. So generative, again, being a broad term, what does generative mean? Normally it's the act of producing content that didn't priorly exist. So you can see that there are text-to-text models, text-to-image models, text-to-audio models. Earlier today, if you heard music playing, for example, on the speakers when you walked in, that was AI generated, for example. Audio to text in the form of Whisper, we kind of like take that for granted. We talk to our phones now, and it automatically turns it into text. How does it do that? Turns out there's machine learning models that do that at various different accuracy rates. Text to video, which is a crazy one, being Sora. Image to image, Stable Diffusion can do this where you can input an image and then output another image. Video to text, being Gemini, upload a video of your meetings and it'll take notes for you and output a summary if you ask it for it. To 3D models, lots of different modalities here is what they call it. And it turns out that because that, if you look at the image on the bottom right here, an AI model is the thing that's being trained. It turns out that no matter what the input is, if you quote unquote tokenize it and put it into a semantic space, not no matter, but it turns out that there are lots of methods to turn the semantic meaning into new semantic meaning in any of the modalities. So as a result, you can input text, image, audio, video, and output text, images, audio, and video. It's kind of like where it seems like the largest of models are tending towards at the current time. So if you look at the timeline of like, man, we hear AI in the news every single day, AI, 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 and there's a bunch of memes online of like, if you say your company is involved in AI in some way, investors throw money at you. If you say maybe Ross will be happy because you use AI at work, it's great. It turns out AI is a very old term. Coined in like 1950s, 1957, the perceptron was invented, quote unquote, and implemented in 1957 and 1960, I think. And that caused this huge boom of people studying artificial intelligence as a whole, up through 1965 or so, it seems. There was an AI winter that happened. It was a little bit before my time, but a lot less people studied it over the course of time, limited by the technology of their era, if you will, because there's no compute power, quote unquote, for what they're trying to do. A lot of people say, wow, there's so much that's possible. And other people were like, there's no way a computer will ever do X, Y, or Z. There's another boom, another winter, and you can see ever since 1990, with the increase of more and more different AI models, AlphaGo, like we talked about earlier, GPT, which stands for Generative Pre-trained Transformers, um, AlphaFold. It's really interesting times we live in. Uh, the state of AI. So this is a couple of really, really cool features that exist now in terms of different companies are producing their own artificial intelligence creations and releasing it to the public. So this one right here is at the top right is called Figure One, and it's super cool because you basically talk at this robot, like throw away the trash, and you see that the trash is being thrown away. Um, so text just to physically actively doing something, absolutely crazy. And on the bottom with NVIDIA Groot, it's a kind of a similar thing where the top one's powered by OpenAI, would recommend. The bottom one is from NVIDIA with NVIDIA Robotics. Their whole goal is to kind of make a foundation model for any robots that you want to make yourself in the future. You basically specify the parameters of the robots, give it the sensors that would have in the real world. They'll train it in simulation, and it transfers to the real world zero shot, which is absolutely wild. Highly recommend looking that into it if you're into robotics, the robotics cross AI fields. Next up, we have Neuralink. Now, Neuralink is not necessarily generative AI per se, but they definitely use AI underneath the hood to detect brain signals. So first, what is Neuralink? So Neuralink is a device that is implanted in a patient's brain. So you can see on the right here, the first human patient is going through trials right now. And the guy on the right there has the chip implanted directly in his brain and is controlling the laptop that's in front of it. He's a quadriplegic, so I hear, so he doesn't have access to both arms or both limbs due to one of his injuries and the C4, C5 of his spinal injury. And this thing has basically completely changed his life. As soon as he got it installed, the very first thing that he did that night was, I think, play a video game until like 4 or 5 a.m. in the morning. Like I would definitely do the same thing. Absolutely awesome. But there's basically 10,000 little electrodes. I think maybe only 1 or 2,000 little electrodes that they have a robot install in your brain, and based on all these electrodes that go in between your brain fibers, in such a way that hopefully you don't bleed, since robots can be just that precise. Yeah, it's not. Um, then they have all these signals that they're able to get out of the brain into a chip that connects Bluetooth to, for example, a smartphone or a laptop like this one or like that one on the screen. And they use artificial intelligence in order to see what's happening in that signal and transforming it into a click or mousing over Spotify and stopping or pausing a song. This one is very, very cool. NVIDIA Blackwell. So there was NVIDIA GTC relatively recently, and it turns out that GTC being a conference held by NVIDIA once a year, where they show off their biggest, baddest GPUs, they showcase this new Blackwell server computer that's able to do a ridiculous number of computations per second in comparison to the previous generation. New, better, wow, as they say every generation. But the reason why this one's really, really cool is because traditionally in AI computers, things are done with 64-bit floating point multiplication operations. And for when you're running your own AI models, it turns out that the amount of computations per second that you need is not necessarily that much. It turns out you can do it with even just 16 floating point numbers. So they've just, by changing from 64-bit floating point numbers to 16 floating point numbers, they don't have to do as many computations, therefore they can do more computations. Or each individual computation is done with less bits, if that makes sense. So you can do more of them. So that's how you're able to get this giant 30x computation increase for decreased power. Very cool. Highly recommend. We have Sora, the text/image to video model. Absolutely crazy. The videos that you see right now are absolutely and completely AI generated. Can talk about it more. Just wow. Suno AI, the music that you heard earlier, absolutely crazy. You can basically type in what it is that you want, what sort of music track do you want. I asked for lo-fi earlier, and it generated the lo-fi. I asked it for just instrumental version. They also have lyrics. A lot of their lyrics, it seems, are sometimes samey, but sometimes quite different. So I recommend just playing around with these tools and seeing your output. Because like if you were to sit someone down and try to tell them what ChatGPT is, you can tell them a lot of what it can do, but without like them kind of experiencing it themselves, it's very hard to like communicate that. So if we're interested, you can totally visit Suno AI, and there's another one that just was released a couple days ago that I don't remember the name of at the moment, but it's later in the slide. It's very cool. ChatGPT gets inpainting. So you can upload an image to ChatGPT or have ChatGPT generate a DALL-E 3 image. And there's a little button on the upper right-hand corner that you click and you just draw where on this, for example, poodle, you want a bow to go. And I just typed in the box in the bottom right, add a bow, and I hit enter. And then lo and behold, a bow is added to the poodle. So cool. Lots of use cases for this. Also, Claude 3 beats GPT-4 on Chatbot Arena. Whoa. So Chatbot Arena is basically a leaderboard, LLM leaderboard, to figure out what is the latest, greatest AI tool. How do you know one chatbot is better than another chatbot? So one large language model is better than another large language model. So this is basically a site where a user will go to, and it'll present them with, like you can type in a question, and it'll present you two different answers, and they don't tell you which is which. And you have to just say which one that you think is better. And so basically these are human eval scores that talk about which AI is the best. And basically to date-ish, it's always been GPT-4 that's on top. But Claude, one of the competitors, released their new model. Turns out, officially according to humans, it's better. Crazy. Although, like 2 days ago, a new version of GPT-4 Turbo came out, which they claim is better, but they didn't provide, OpenAI didn't provide any benchmarks for it, unfortunately. So I don't know if it's on the leaderboard yet or not, so who knows. Mistral, which is the very largest open source model distributor, I'd say, released their new model, Mistral 8x22b. Essentially, if you run open source models, this is a thing to look at, although you need lots and lots and lots of VRAM in order to run this locally, which we can talk about later. Okay, so those were a bunch of the different announcements that happened. Very cool in the space. We also have practical uses of AI. What is it that AI can do that helps me? Yeah, how do we get practical work out of these AI systems? Essentially, for large language models, it comes down to two things. One is you got to identify a use case, and two is you got to do lots and lots of prompt engineering. Lots of us have heard prompt engineering, but just to define it for those who don't know, prompt engineering is the act of typing in a sentence or phrase into an LLM system or a chat model system of what you want it to do, and how well it does it can be very hit or miss depending on what you ask the model to do. And as a result, it turns out there's a whole engineering aspect behind, oh, you got to ask it a little more this way, a little more that way. You got to like threaten to take away its lunch money or like please beg it. And it turns out like these little things, it turns out that act on the human psyche, since ChatGPT was trained on human data, things that work on humans work on ChatGPT from like a psychological perspective. Very interesting. Here are 3 resources I strongly recommend looking at in terms of prompt engineering type stuff. OpenAI has a cookbook. Anthropic has a cookbook. And Anthropic also has just a straight up prompt library that's very similar to just use cases of these are really cool prompts that actually might be useful. I'm going to say these really, really fast, but there's a lot of things ChatGPT can do, including explaining code, writing emails, talk you through an idea, give you ideas through ideation, organize to-do lists, analyze plot data, aggregate spreadsheets, make recipes, compare and contrast ideas, editing, identify tools that need help to projects, it just helps you create things in general, create a workout, coach you through something, organize a resume. It's crazy, like every day people come up with new use cases. I frequent x.com/Twitter, which is maybe a bad idea, maybe not, I don't know. But I can see on this top right one here that this guy was talking to his vet, and his vet was wondering what it is that what the issue with his pet was, and he was able to work with the vet and ChatGPT to like identify what the issue is. Kind of like a recurrent theme behind use cases seems to be that eventually people are like really worried that AI is going to take your job, and maybe one day it will. But at least in the interim, as it exists today, there's a human that can perform, and there's an AI that can perform, but AI plus human seems to be giving the best results as of today. There are downfalls of ChatGPT/LMs in general. For example, if you ask it to please generate a blog post article for me, let's say you're trying to do some creative media for your business, it turns out that there's a very generic vibe about it that is very detectable over time for people. So on the bottom right here, ChatGPT helped me improve my landing page. It simplified language, made content more relatable, and created a great tagline. Now I'm confident my page will generate more traffic and better outcomes. Thanks to ChatGPT. Hashtag no code, hashtag no code institute, hashtag Canva, hashtag ChatGPT. It seems like something that someone could post, but because Chandler and I have looked at tons and tons of generations from ChatGPT, you can kind of identify different phrases about it that kind of lead it to being way more likely to have been generated by ChatGPT that might not be initially obvious upon first reading. Uses certain phrases, certain words really regularly, etc. Tweets contain hashtags even if you ask it not to, for example, is one of those quirks. AIs also hallucinate. They make up fake things and confidently say that they're real, which is a problem for sure. It'll have dated information. ChatGPT was trained at a particular time. If we're talking about a new technology that just came out 2 days ago, ChatGPT is not going to know about it unless it has access, for example, to read the information and like put it in context, which some AIs are getting right now. There is a learning curve to learning prompt engineering. It has inherent bias based on its training data. There's a bunch of privacy concerns. When you give one of these AI models your data, technically like whatever you're typing in that chat box is going up to OpenAI servers, and they're returning an answer to you. And they do have a license and they tell you what they do with the training data, but also, are they honest with what they say? It's up to the individual or corporation to decide what is safe for them or not. I think, for example, for the more personal use OpenAI license, they basically say that it is possible that anything you put into it might get leaked inside the training data. For example, I think there is a case where a Samsung engineer had very technical documents that they wanted to be they were like asking it, how do you do a particular type of like chip design? And it turns out the people at AMD were asking ChatGPT, how do you do a certain type of chip design? And they used the one prompt to like train it. So then AMD was able to get things out of ChatGPT that were proprietary NVIDIA data, or proprietary
Samsung.
Yeah, Samsung data. Thank you. And I've heard like many stories like that too. That's just one such one. There's misuse potential. There's economic and employment impacts. I was talking to someone the other day that worked at Progressive, and I asked him the question, what does it look like? What does AI look like in terms of hiring? And he basically told me, I don't think that like anyone here is going to lose their jobs, but one thing that is kind of interesting is a lot of our people are now able to go much further. So we don't think that we need to hire as much to do as much because each of our employees is being able to do more. So it turns out that like it may not be eliminating jobs, but it might be eliminating new jobs, if that makes sense. So there are great impacts that happen because of AI. There can be regulatory changes, LLM change over time. You don't know where the initial training data was, refusal. There's just so many things that are downfalls of ChatGPT that really need to be talked about and discussed and taken into account when you're using it for particular use cases that might be more sensitive. Now, just because there's downfalls doesn't mean that you can't overcome the downfalls. And to overcome the downfalls, one of the easiest ways to do it is just to keep a human in the loop. Have it fact checked. Is this thing legit? Does it make sense? One of the really, really good talks on this that I really enjoyed, I have a link to this. There's, again, slides that I can provide after the fact. But NVIDIA had, as part of GTC, a bunch of different people who came and gave talks, and one of which was, for example, Ford. And they put together this really great presentation, in my opinion, that they talked through how they were able to limit the downsides of ChatGPT while emphasizing the upsides. And they were able to create this document that was able to have what's the name of a person who works on a car?
Mechanic.
Mechanic, yeah. So they were able to have mechanics. Mechanics need to fix lots of very niche things, right? You bring in your car, there's lots of different makes and models, and there's lots of different types of things that happen inside of a vehicle. And it turns out, previously what was done is you have this giant corpus of these car manuals / books that you have to go through and analyze, how does this thing work? Okay, this is how you take it apart. And then do it in reverse order to put it back together. But now they just have a little chat interface where they can type it in, how do I fix this spoiler on this version of this car? And it aggregates it all together. and outputs it for like knowledge information sharing. Very, very cool. Earlier today, I talked about blog posts and how they can there can be an issue with how ChatGPT speaks in a certain way. Well, it turns out like you can ask ChatGPT just to like eliminate certain words from its vocabulary, or change the different phrasings like after the fact. Sometimes you might not just prompt once, you might prompt it, get a response, prompt again, get a response, prompt again, get a response, to like iterate over time to eliminate some of those issues. How do you write good prompts? This is a whole like deep dive in and of itself. So I'll only like cover the very basics, which is that you need to speak clearly in what it is that you're asking. If you were to take some random person off the street and give them the instructions of what you want them to do, would they be able to do it, given only that information? It turns out if that situation is true, a lot of the times it can give you that information. Maybe not in exactly the way that you asked, but it'll be there more or less. But there's also a couple other few tips and tricks that you can do. One of which, for example, is few-shot prompting, where you give it a bunch of examples of what you want, and then it'll return an even better result. Another one is chain of thought prompting. I don't know if you think back to your time at grade school, you had to do your math homework, and your teacher would mark you off points even though you got the correct answer. And the reason is because you didn't show your work. So it turns out, why does a teacher want you to show your work? If you go through and you show your work, in addition for them to tell if you're doing it right, I guess, is way more of the students actually will answer correctly. And the reason is because they're thinking through the different reasoning steps and writing them down, and then you get a correct answer. Turns out ChatGPT behaves very similarly. Because asking ChatGPT, for example, to do math is like asking you to do mental math. Quick, what's 348 times 22? Like, do you know it off the top of your head? Like someone who studied a lot maybe could do it off the top of their head. Hence, ChatGPT has studied a lot of math questions really, really well. So it can do that sometimes, though. So instead, you ask it chain of thought prompting. Okay, first this number times this number equals this number. Then you take these, carry the one, et cetera, et cetera. So there's a really, really, really good prompt engineering guide that I like. There's a link to it. Would recommend checking it out. Getting your prompt to 97% accuracy. There is a crazy art to this. And there's a really, really good talk by OpenAI called A Survey of Techniques for Maximizing LLM Performance. And I would strongly recommend, if you're trying to get that like more and more use case out of your prompt engineeringness, to check out this video. Because step one is you want to prompt engineer. But then it turns out that there's a limitation. For example, let's say you're trying to do something based on your company's data. It turns out that there's a technique for that, for inserting new information into ChatGPT that ChatGPT doesn't have, called RAG, or Retrieval Augmented Generation. And that's where you should go if you're missing information. Another thing you can do is you can what's called fine-tune the LLM to what a lot of people would think would happen is like you're adding information to fine-tuning, but realistically, normally in a fine-tune, there's a lot of dependencies. It depends. But normally, if you're doing, for example, LoRa fine-tuning, it's for changing the structure of your data. So before a prompt that you might ask it 10 different things for you to do, if you provided a bunch of examples of inputs and outputs and what you wanted to do in that step, when you give it another input after fine-tuning, you don't have to give it those 10 things. It just knows intrinsically to do those 10 things, and therefore your prompt can be smaller. And smaller prompt means you're using less tokens, which is good. But yeah, TLDR, if you're trying to get really, really good performance out of your LLM, watch this video. Very, very insightful. Also, words of advice to myself and therefore everyone is to get it working and then optimize. So use the biggest, baddest model that exists. For example, there's GPT-4 and Claude to get it working, and then you can optimize on smaller models like ChatGPT, like GPT 3.5, or Claude Haiku, where you give it a bunch of examples and try to like optimize the performance out of it. Because people online have given this advice because there's a lot of individuals who say, oh, an LLM can't do this task. And it turns out they didn't use a smart enough model. And so when going to a smart enough model, it's able to do that task. And then later, it turns out that the small model could do the task the whole time. It just didn't prompt engineer it well enough. So $30 per million tokens versus $2 per million tokens is a big deal. So speeding up is a really good thing. So the next thing I want to talk about is the difference between kind of like tasks and chatbots and agents and workflows. It turns out that these are kind of like very, very different ways of using ChatGPT that I find very helpful. So a task is to do a simple thing to accomplish a goal. When you have a thought of, oh, ChatGPT maybe can do this, you'll go into ChatGPT, you'll type it in, get a response, like you trying it. Like the act of doing one like chunk of work in general have been called tasks online. We have chatbots that you're more familiar with, ChatGPT. The act of going to a chatbot and having that interface and asking a bunch of questions. You have agents where agents go around and like kind of like accomplish their own goals and workflows. Now I think about it, I think I have these broken out. So yeah, there we go. So example tasks. So this is where you want to go and you want to do something. So we have a, let's say you want to generate a web app component. Let's say you're responsible for making a website that serves toast or something, and you want a way to put in the different types of bread that you might want to do. That will eventually turn into toast. You might need like a drop down to select the different types of toast that exist. In order to generate that drop down, it turns out there's a really cool application that you can use called V0. You type it in, bam, it generates it. You can have different tools generate unit tests for you for your code. You might want to produce raw files, backgrounds, sound effects, character designs, particle effects, graph generation, meeting summaries. There's lots of different like random tasks that you can have these chatbots do. And you can iterate it over time with chatbots. So you can also integrate, RAG systems, retrieval augmented generation that I talked about earlier. For mechanic niche thing I talked about, and yeah, chatbots. You guys know chatbots. You guys have used ChatGPT. Workflow examples. So this one, I think, is one of the biggest, Chandler and I have seen the biggest proportional gain of knowing this technology compared to other different implementations. A lot of people, I'm going to skip and go back to it real fast, talk about agents a lot, where you have an AI that gets loaded and has a goal. And it'll try to accomplish that goal over time. And sometimes it's an orchestration of many agents. Sometimes it's just one agent that cycles different prompts through it. There's a lot of different architectures and structures for this. But essentially, it's the idea of you take a chatbot, you tell it a goal, and it has to figure out step one. It might list out all the different steps it might need to do. And then it will go through each of those steps sequentially. And then after it outputs that, it might look at what it outputted and ask itself, was that good enough? Did I accomplish my goal yet? If I haven't accomplished my goal, what else should I do? And it comes up with another list of things, and it goes through those things, and it's like a very recursive structure, and can get very expensive very fast, and also can like go on very like side tangents. Like if you ever have like an intern work on a project with you, and you ask them to do something, and then did not talk to them after a long time, you go back to it, and you're like, what are you doing? And it's like off in no man's land, not where you expect it. It's kind of very similar thing with agents, because there's no like human in the loop process. So agents can definitely be improved with human in the loop. But the disproportional games, again, I think is with workflows. And the reason is because what you do is you kind of define a sequence of step-by-step tasks that you want a LLM to do. And with that, you're able to kind of get more results that are more normalized throughout a process. So you, again, need to identify a use case. So a couple of use cases I have listed here is, suppose you want to just make your whole website. You want to be able to click a button, or type out what you want your website to be, click a button, and it'll generate the whole website. Step one is you break that up into different tasks. Like in our mind, might be able to ideate together what tasks, how do we go through, and how do we accomplish this? And then given all these different tasks that all of us decide, we break it up. We do step one, see what the output is. If it's good, we might iterate. If not, for good, go to step two, step three, step four, step five. And eventually, you get this nice reloom document that has each of the different components. Reloom to Figma to Webflow. Webflow is a online website builder similar to Wix or Squarespace, but a little bit more in depth. And Figma is a tool that you can use to make like UI design mockups that are really, really nice. And Reloom is an AI tool that can make, it uses like ChatGPT under the hood to make a bunch of different web components that can be imported into Figma. And then Figma has a thing where given a bunch of Figma, it can turn it into a Webflow document. So using this workflow, you can get straight from idea all the way to website with minimal clicks, which is really crazy. And then you can edit it along the way too, since Figma, you can edit how things look and stuff. You can make, for example, one that goes through each of the different leads that you have. Like let's say you're trying to sell a product and you got to call a bunch of people over time, rather than you sitting there and calling each different person. For better or for worse, AI generated voices here. So one of the different ways that we can do is make an AI system that goes through and figures out who they are and what they're doing and how our system might help them. and it'll go through, it'll call them up, it'll be like, hey, are you interested in X, Y, and Z system? We think it can do A, B, and C for you. Would this be something that you're interested in? If yes, if no, maybe ask a couple more questions, and then be like, all right, awesome, I'll get back to you. And put that into like a database with a nice summary, and then I can come in the next day and be like, oh, hey, here's a bunch of all the different people that were called the previous day. Let's suppose that almost all of us attend meetings, I imagine. As a result, uh, all of our meetings are online and are recorded. Turns out you can take those recordings, grab it, turn it into a transcript, take the transcript, throw it into ChatGPT, and give yourself notes on said topic, or maybe ask who said what at what time, what day. Very possible integration. Um, Meme generation, you can see that meme right there. AI is stealing our jobs. And then meanwhile, the AI is used to generate trending cat memes. I like this meme a lot, especially because I know that it was generated by an AI that I made. So it's an AI generated meme. Very, very fun. There's a really, really cool tool that I recommend for a lot of people who want to do this integration type workflow called Zapier. Um, and really a combination of these large language models crossed with Zapier integrations. Like there's a lot that can happen there. And then generating tweets and stuff. So very, very powerful stuff. Another really cool practical use of artificial intelligence is GitHub Copilot. So um, I've heard the phrase online a lot, and also from friends, that the skillful part of coding is not necessarily writing the code, it's knowing what to code, what code to write, or an equivalent of like, well, AI will never take our jobs because rather than that's kind of like you're having an assumption that people will know what it is that they want you to do or what to write because requirements change a lot over time. But essentially, this is a really, really cool tool that you can just plug into your like VS Code or Vim or NeoVim configuration, and given a autocomplete, like when you start typing, it basically keeps track of what it is that you've written before. And if it thinks it knows that it can what it is you're going to type next, it'll put it there in like a nice light color, and you can hit tab, and then it'll autocomplete it, which is super duper cool.
Play the video again.
Button.
And then explain it.
Yeah. So here you're just writing a comment, for example. This function gets all the pull requests for a given repo, and then you can wait while it does the query in the background, and like it just recommended all this, and it turns out that this guy right here is a working piece of chunk of code. So it can really speed up developers. When talking with a bunch of developers and whether or not they use Copilot, I've seen different reviews across the board, to be honest. I've seen some developers say that it sped up their workflow by like double, triple, because they have to write a lot of boilerplate code, and ChatGPT really excels at doing boilerplate code. It turns out that a lot of the code that we write is boilerplate, despite us thinking if we're doing something novel or not, because how many times do we need to write something on a web browser, make a button show up, or have on a button click it sends an HTTP request? Like all these things are very, very common. So it does very, really well at that. But then there are like senior engineers that are like really, really deep in like TCP socket stuff, and like they're performing it in a new way, and a new architecture doesn't exist yet, and it doesn't necessarily do as well in that task. So it just depends. Yeah. Also, we can use these artificial intelligence tools via an API or through like the web interface. So let's suppose that you're writing an application yourself, or you have your own website, or you have your own tool that wants to go and do something. Instead of needing a human to sit there and type into ChatGPT to get the response and to give it back, you just issue a small little API request. We can see the code here on the right-hand side. It's not too much. You identify OpenAI, you say what model you want to use, and you give it the little text that you want it to do. For example, what are some famous astronomical observatories? And then you hit enter, and then off the request goes, comes back, and your application will be able to have the power of ChatGPT or the equivalent. Gemini offers an API, ChatGPT offers an API, Claude offers an API, Microsoft offers an API technically. So yeah, just Google the AI that you want to use, space API, and you'll get lots and lots of information about it. Retrieval augmented generation, RAG. I've said this phrase a couple times in this talk already, but it's also really hard to know where to put things because everything's like interconnected in like a web. But retrieval augmented generation is essentially a way for you to inject information into your application that the AI may not have been trained on. So suppose that you work at a company that makes, some some proprietary thing that wasn't in the ChatGPT code base. Whenever you make a request, um, the system will turn your request into an embedding, which is a internal representation that the AI kind of understands what the semantic meaning of the object is. What do you mean? And you have all of your documents that ahead of time you've also embedded and put inside of a vector database. And using a vector database plus your query that was quote unquote embedded and vectorized, you can do what's called a similarity search, where you can get things that semantically mean the same thing. And as a result, inside of a prompt then that you normally prompt ChatGPT, you first put your documents that are relevant to the question and then your question, and then you can get a response. And how do you know which of your documents is relevant to the question? It's this embedding vector database combination, which is also called RAG. So you retrieve and then augment the generation, which RAG is a very funny name for it, but it has caught on apparently. Very fun. Running your own local LLM. So there are a couple really, really cool tools in case if you don't want to use, for example, an online component where you're sending away your data and you don't know necessarily what they're doing with your data. And it turns out that our computers now are powerful enough to run some basic large language models. So one really, really cool tool I recommend using is Ollama. So Ollama on the bottom right here is a really, really cool command line interface tool that's available for Mac, Linux, and Windows. Although I think in Windows, technically it runs in Windows subsystem for Linux, so it's technically Linux, but on Windows. But after it's installed, you can literally type in the command Ollama space run space the large language model you want to run. And then a chat interface will come up um, in your command line interface, like in command prompt on Windows, for example. And you can type in your question and hit enter, and your computer will sit there, not connect to the internet, and process a bunch of different matrix multiplications and return to you a result, which is really, really interesting. So yeah, Llama's a really cool tool for that. If you're looking for something with more of a GUI, a user interface, something that you can like interact with, then LM Studio and Chat with RTX are both really cool tools. Chat with RTX is only on Windows, but it's offered by NVIDIA and you need an NVIDIA GPU, but you download it. And that one's really cool because you can specify a directory of a bunch of different documents that you have. And then in that document, or in that chat window, you can ask it about the documents and it'll be able to like give you information back. So let's say you have a bunch of your PDFs about like documentation that you're interested in. You throw in a directory, you select that directory, and you go like, how do I implement this TCP socket? And then it'll be able to tell you. Very, very cool. If you're looking to actually host an LLM, normally you use something with this fourth one that I mentioned called VLLM, where it's this crazy turbo fast, like only run it on giant GPU Linux computers, where it will then host your model for you at crazy speeds. So you can, for example, chat with Mistral 7X22B is one of the models I talked about earlier, all locally, super duper fast. Other things to know about, though, when running your own large language models locally is about licenses. So technically look at it to see if it's like Apache 2.0 is Mistral is one of my favorite models. So that means that it's open source and you are free to use it and free to use its outputs and generations. So do some research into licenses if you are going to use it locally. Also, the larger it is, the harder it is to run, the smarter it is. There's a trade-off there. Quantization is a thing that you can do in order to get a larger model to fit in a smaller GPU, but a lot of these systems do that automatically already under the hood for you. And there's also fine-tuning, which I mentioned earlier a little bit as well. Which large language model do you use? That is what benchmarks are for. So benchmarks are a good quote-unquote approximation of how good your large language model is. Although it turns out that there is a way to do very, very well on this leaderboard that we talked about earlier. Here's another one that is offered by Hugging Face that showcases a bunch of different benchmarks. One of the benchmarks is called Hello Swag, which is kind of fun. That is a collection of ACT questions in multiple languages and this is like how well each of these models perform on it. But it turns out that if we wanted to, we could train our own model on those benchmarks, and then it would do really well in those benchmarks and not do really well in real world. So it really depends on, you got to look at the average across many benchmarks and also like interface with it and get a vibe to know if it's good or not, is a TLDR. You can also run these large language models on the cloud. So you kind of own the infrastructure in a way because the cloud provider is just kind of like setting up these systems for you, and you're the only one that's using that. So no provider, uh, most likely, I mean, there's technically anything is possible, but a provider won't go into your container and see what's happening. So if you, for example, trust Cloudflare or NVIDIA or Azure, you can just go to any one of these websites here and just they offer a web interface. You go on, you select what model you want them to run for you, and you hit go, and then they host that model for you, which is really, really nice. That way, if we ourselves don't have GPUs that have 900 or 96 gigabytes of VRAM, we'll be able to actually run them, which is really, really cool. Run like a more powerful model. For local LLMs, there do exist, for example, one of my favorite ones, like I said, is Mistral 7B, and that's because you can run it pretty much on everything, including my laptop right here. Image generation tools. I talked a lot about large language models, but that's only one type of generation, right? So you have Midjourney, DALL-E 3, ChatGPT, Microsoft Copilot has a UI that you type into it, and it will generate DALL-E 3 images under the hood. A lot of the hosted online versions of Stable Diffusion, like I said. Um, this is one of the very best art videos that I've ever watched in terms of how to get the most out of the generations that is performed by a image generation model that you want to actually go and do something with. So this guy is hacking Midjourney for insane ad creative. This guy was able to take a Midjourney prompt and be able to, in addition to making a lot of images that look really, really nice, customize it towards a specific use case for a bunch of different clients. So we have Uber Eats here. A lot of us use Uber Eats. Turns out a lot of the creative that while we're scrolling Instagram is AI generated today, for better or for worse. Another guy on the right here, which I thought was a genius use of the image generation, is this guy can sketch. Like a very, very, very cool tool. So he just sat there one evening and drew a sketch out of like a level that he wants to include inside of his video game. And so he, from that, you can just throw it inside of a image generation tool, and kabam, you have your art for your video game. Now, it turns out for image generation, just like you can do it online, you can also do it locally. So there's a guide that I've linked inside the slides I highly recommend if you ever want to know how to really, really customize, how to get in-depth detail what you want it to generate for you. One of the best ones that I really like is called Comfy UI. It's the drag and drop interfaces I'm showing you here, where you can have a positive prompt and a negative prompt. Positive prompt is what you want to show in this image that you generate, and negative prompt is what you don't want it to be. So one of the things in negative is you don't want it to be blurry, you don't want it to have text, you don't want it to be out of focus, stuff like that. Invoke AI is also another really, really good tool for running running image generation stuff locally. Highly recommend.
Does anyone have any questions on anything they've seen? Well, I know we've shown quite a lot before we took a break for questions. Does anyone have any? Yeah.
So the hosted AI tools, do you know what the privacy of that is?
It depends on the hosting provider. So if your company primarily uses Azure, it's going to be governed by Azure. Some of the smaller companies, they're actually like white labeled Azure, white labeled AWS, so they still follow the AWS rules on top of whatever rules they also enforce. So it heavily depends on which one you choose.
Just read up on the policy.
Yeah, read up on the policy for whichever hosting provider you chose. Any other questions?
When it comes to like training your models, like what's your guys' rule of thumb for training versus using RAG or some other thing?
We follow the agreed upon rules that are like currently the industry standard, which is you first try to you prompt engineer the crap out of it. You then, all right, I'm not getting as good of a result as I want for either the output. If the output's not good enough, then we will do a fine tuning. If the information isn't good enough, then we'll do a RAG. Your last resort should always be fine tuning though. You should always try to prompt engineer as much as possible because the second you try to fine tune, your cost goes up and it can go up by a lot. Like it can go from oh, this project cost me a couple $100 to a couple thousand to a couple $100,000. Like it balloons quick because you need the data, you need the GPU compute power in order to fine tune it, and you need all these things. Kyle's also going to go over some methods to fine tune on the cheap. I fine tuned a model for about $300. It's as cheap as I got it, but I already had the data and I already had the knowledge to do it. So if you don't have the knowledge, it's going to cost you a lot of time, and if you don't have the data, it's going to cost you a lot of money to get the data. So, and then for RAG, it's almost just if the information's not there, we need to do a RAG. It's just how it is. That's just the rule of thumb currently.
What about when to use What about when to? Yeah, thank you. What about when to use one of the publicly available models versus like our own model?
Always use the publicly available first, especially for development because it's cheaper. Just at the end of the day, it's cheaper.
As long as you're okay with their like privacy policy though, right? So if you're really focused on privacy, then only doing local is your only option. So it really depends on where you are in that spectrum.
But using it just for development, like a publicly available model, when we say publicly available, we do mean like the pre-made, like OpenAI and Claude, and the ones that you can just go and pay for and you have it immediately.
Also, like for example, OpenAI offers a couple of different levels of subscription. At the base level subscription, they say that they will train on your stuff. At the higher level of subscription, they say we won't train on your stuff.
So yeah, it also depends on what tier of customer you are, because if you're progressive, if you're a massive corporation, they're going to be a lot more open to working with you. But if you're some random developer in rural Ohio like I am, they don't care.
OpenAI does offer a fine-tuning API also. So in case you want to fine-tune OpenAI, they have a set of instructions for that on their website.
Okay. Does that answer your question? Okay. Any Jack?
I like the tag team you guys are doing. For RAG, how would a normal user go about like inputting the data you want, having it like compile and regenerate every user?
So if you notice this graph, there's this little bird and chain logo down there. That is for what's called LangChain. LangChain is a publicly available open source library for Python and JavaScript that allows you to, they provide a bunch of tools to like automatically take a document, embed it to what you want, put it into a vector database, which we can go do a whole day on vector databases. They're complicated and cool. And then from there, LangChain will automatically query that vector database and embed your content within the prompt. That's how a RAG works. All a RAG does is take whatever company data or information that you have and embed it inside of the prompt to the AI. It just does it in a very abstracted way, so your end user doesn't know it's doing that.
I've got part two.
Continue.
With like a local, like say you have like I don't remember your examples, but say like a cookbook directory, just have all the recipes. How would you go about training and to use like a directory on your computer?
So Chat with RTX offers that just built in. How it works is that it does the thing where it splits up the documents into chunks first, and then it does that embedding on them and then puts them into a vector database. We've done that as well. We developed an internal project called SearchBase that does exactly that, where it just has an upload button. You can upload like a dozen documents to it, and then it will automatically process each document. And then you can either use OpenAI or a local LLM to then query the database and then generate answers. Any other questions? Yes. Okay. That would be a Kyle question.
One of my last slides, I think, answers this exact question very well, which is what tools outside of this talk. So there's lots and lots of information here that I'm just like fire hydranting onto you guys. Where do you go after this? And so I'm going to bring that up near the end here. So cool tools. So this is a bunch of really awesome tools that Chandler and myself use. We have we're gonna basically re-mention a lot of the ones that we talked about earlier, but in kind of like a more streamlined way. So kind of maybe jot down the ones that matter to you, depending on what your use case is and what you're trying to do. So there are the 4 main large language models offerings. There's ChatGPT, there's Claude, there's Gemini, there's Microsoft Copilot. I'll list a couple other ones here audibly. Mistral offers their own through Microsoft or through their website. Another really good one is Grok, G-R-O-Q. That one's specialized around tokens per second. They run it on a very, very specialized CPU in place of a GPU. Very, very cool. Called an LLU, I think. Very cool. Custom GPTs is a feature inside of OpenAI's ChatGPT website. If you go to chatgpt.com, you look in the upper left-hand corner, there's a GPTs button. And if you click this, it's a bunch of customized generative pre-trained transformers that have been pre-prompted in such a way that it can do a bunch of other really cool things for you. So just on this screenshot, we can see that there's a music teacher, there's Adobe Express, you can chat with PDFs in some of these, one specialized on image generation. Some of them have integrations to Canva. That's another thing to mention about custom GPTs is that they can have custom integrations with APIs offered by the company that made them. So for example, Canva, which is a website for making UI kind of similar to Photoshop, but more like has a couple like smart features, quote unquote. You can ask ChatGPT to make a certain type of component for you in Canva, and it'll make the component and call the API on your behalf, and will make an actual Canva document inside of the Canva UI interface. So searching through all of these and just finding like really cool use cases, highly recommend. Running large language models locally, there's Ollama on the bottom right that we talked about earlier. Under the hood, in case you want to do what Ollama does, but more directly, there's Llama CPP in the upper right, which is a file that is on your computer to run large language models implemented in C++. There's VLLM for if you want it to run super duper fast on the internet on Linux GPUs with lots and lots of VRAM, hopefully. There's LM Studio. This is a really, really like easy to use, has a nice graphical user interface, and works on both Linux and Windows and probably Mac? Question mark? Do you know?
Yes, it does work on Mac. Actually works the best on Mac in my opinion.
Actually works the best on Mac in Chandler's opinion, he said. Very cool. Which models do you run? So on Ollama's website, they have a Ollama library
Repository.
repository.
It is, yeah. Because you can upload your own.
Yeah,
I've done it.
Yeah, Chandler has uploaded his own. If you were to fine tune your own, for example, you could upload it to Ollama, and then when you go to another computer, you can type Ollama space run space whatever you called it, and then your model that you trained will go from the cloud to your computer. It's kind of like Docker if you're familiar with that, but for large language models. Very neat. But in this list here, they have a lot of like the very most common used ones. You can see the number of polls, and you click on it, and it has a nice model card for you, which is like a description of what an AI does. And they each do different things in different ways. That can also be a whole topic in and of itself. Very interesting. Another way, how do you know which of those giant systems to use? You look at different comparison charts. You have benchmarks that exist. A lot of them are on this website called Hugging Face, which is really cool. Even though that a large language model, again, can perform really well on these, does not necessarily mean it's good. My favorite example is that Google released Gemini 1.0 and Gemini 1.5, which are these awesome, super large language models. And they wanted to get a little bit of nice lip service and press by releasing an open source model for everyone to use. They released an open source model called Gemma, or Gemma, G-E-E.
It's Gemma.
Gemma?
Yeah,
Okay.
Gemma.
However, when you install it via Ollama and try to get it to do something that's not in one of the pieces of training data, for myself, I've had very sour experiences with it. And there's a nice YouTube video at the bottom here if you want to look at it afterward, the fact on the slides, that was someone else who kind of had a similar experience to myself. But also use it for yourself and see what you think for each of the models. Some of the other coolest AI tools to date, there's a lot on this slide. I probably won't go through all of them, but they're here in case you want to look through the slides after the fact. But ChatGPT, OpenAI API, Stable Diffusion, Suno AI / Yuyo is like the music that we were listening to earlier. 11 Labs is for making voice like yours and mine. I can record a 10-second clip of me talking right now and then like type in what I'm going to say and put the microphone on my MacBook and walk away, and it'll do the presentation for me in my voice, which is kind of nice, neat. Ollama we talked about, Hugging Face, great website for downloading models and having model cards, and they also have a bunch of resources. Speaking of resources, Hugging Face, they have a lot of resources on learning artificial intelligence stuff. Studio, V0. Yeah, lots and lots of tools. One tool that Chandler found 2 days ago,
Yeah, like yesterday,
yeah,
pretty much. Yeah.
like yesterday, was this
And
really,
I stayed up all night playing with it because it was so cool.
yeah. He stayed up all night working on it / playing with it because it's just so cool. Essentially, it allows you to host your own LLMs on it. It has a chatbot interface. It allows you to create those workflows that we talked about. Normally, you have to like write your own Python program to do it, or make a Zapier integration workflow to do it. This is a nice UI that focuses just on LLMs to make workflows that we had a lot of success with running it ourselves. I think they have an online version as well, but I like open source software that we can host ourselves.
Yeah,
It's
you can
nice.
self-host this one on your own infrastructure, or here, can I see it? You can self-host this one on your own infrastructure. It's a little bit weird because it's very early beta. It's like they just came out with software like a month ago. But the hosted version is well behind. Like the hosted version doesn't have workflows yet. Agents are still really iffy. So like this is early software, but I look forward to them updating it because I'm very excited for this.
Yeah, unfortunately, like almost all of the AI software is early software still at this point. So, but it just depends on what you're trying to use. But totally agree with what Chandler said. Other cool AI tools that are just like nice links to look through at your leisure. There's a workers API from Cloudflare that will deploy some of this stuff for you on your behalf. LangChain is the Python library that we talked about earlier. I think they also have a JavaScript implementation as
and
well.
an unofficial Go port.
And an unofficial Go port. We have the Model Garden offered by Google, as well as NVIDIA's equivalent, where you can just, with one click, host your own AI models on NVIDIA hardware online. Question for you guys. What AI tools have you guys used that I did not just mention? Cricket.
Yeah.
Cricket. Any AI tools? Question mark. That you guys have used in your guys' past that I have not mentioned so far in the slide? Wow, that is unexpected.
I'm going to give you another break.
Okay.
Any questions at this point? Nothing? No one's questions? Just giving him a break for a second.
I mean, how you said you spent all night working with Dimby. Is there anything that you like did with it, or
It was more like me experimenting with it. I think I built a little like blog post generator where given like a topic, it would like do a Google search and get me a bunch of sources and it would try to write a blog post about it. But it suffered from the same problem that we talked about earlier where it sounded like ChatGPT wrote it. So I'm still working out that bug. So any other questions? Going once, going twice? All right, back to Kyle.
Huzzah! Yeah, there are lots of tools online that quote unquote utilize AI. So I think that trying to share them between us is going to be very, very, very cool. So this is kind of like a whole different section of like, how does AI work under the hood, right? There's the what AI exists and what is AI, which again is a very broad term and I have only even loosely defined it myself. Then there's how do we practically use it on day to day, which was identifying use cases and then physically prompt engineering over time to get the use case, or doing image generation engineering over time. So also prompt engineering over time doing it. But then there's how does it actually work under the hood? And how do you like make your own AI? And how do you train your own AI? So we're only going to lightly touch on this just because there's so much information here, but we're going to try. So what is a model? So this guy right here is a plain vanilla multi-layered perceptron, quote unquote, a very cool sounding name. This is a many of these layers stack back to back to back to back to create what's called a deep neural network, where each of these layers is essentially a giant array of numbers. So you can see this little screenshot, this number 4 on the left-hand side. If you look at each of those pixels, where a value of 0 is perfectly black and a value of 1 is perfectly white, and between 0 and 1, like 0.5 is like gray, and you map each of those pixels to an input, it turns out that after you go all the way through the model, after it's trained, doing a bunch of different math stuff that I won't get into right now, but I can get into if we want because it's really, really interesting. It turns out that we can use it to estimate what this number is. Is it a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10? Which is super cool and actually performs extremely well. Although there's one feature missing from this one, as you can see. If I were to just like scribble, not write an actual number, it'll confidently say, oh, that's a 7. So in your models when you're training them, you probably need to, encapsulate almost all of what you want out of it. If you're just looking for what it is this digit, this is your guy for, this particular purpose. So essentially you have this giant matrix multiplication model that is a collection of weights, and it's really hard to like identify how deep you want to go. But basically, it's a collection of weights that gets trained over time using this algorithm called backpropagation. And where you give it a training data set and you put in an input and it gets an output that's wrong because it's not untrained. And then you take the difference of what it is and what you want it to be, and you backpropagate it through, and you try again, and then you do that, and you try again, you do that, and you try again, and eventually get smarter and smarter and smarter and smarter. And if your training data is very representative of what you want your actual data set to do, then it turns out that these models actually learn really cool, interesting patterns. What is one of those data sets I just talked about? You have, for a large language model, for example, like ChatGPT, it's trained basically on the entire internet. They don't actually release what their training data is, unfortunately. Pretty much no company does at this point, even though they're like quote unquote open source. There's open source means a lot of different things, right? There's open weights, as in they'll let you download the model and run it. There's open code, as in they show you the code that they use in order to train it and like their whole architecture. And there's like totally open source, which is like they showcase all of the data that they use to train their model on. So data, code, and model weights are kind of like all three different separate things.
Most models are just the last two.
Most models are just the last two. So this is a data set that exists on Hugging Face. One of the things that Hugging Face does is they offer a lot of data sets online that you can use to train your own models. They have like different licenses for each of the data sets. And also Kaggle is another really good one. But you take this giant data set, you put it in front of this model that learns stuff through backpropagation, and it learns data and it transfers that into real world performance. So step one, you take your data, put it into a model, you get your output. Before training, the model just outputs garbage. During training, the model's training on that data set, and after training, the stuff that comes out of that model can be sometimes good. There's a very popular phrase, garbage in, garbage out. If your training data is garbage, quote unquote, then your output might be garbage. One of the interesting things, though, is I did watch this talk from NVIDIA GTC where they were using ChatGPT to clean up data. So they had a bunch of this unstructured data, and they had a database of where they wanted it to like kind of go in. And normally they'd have to have a human look through this giant data pool and kind of create your data sets. But they just made a nice pipeline workflow to turn this unstructured data into structured data. So it's kind of interesting because we've come full circle now to where ChatGPT that was trained on data can be used to quote unquote purify a data set that can be used to train another model. So it's very cyclic in its nature. It's very interesting. Also, there's this really neat paper called the Chinchilla paper that I'd recommend that talks about how much data do you need per model size. So there's this concept called tokens that I haven't even talked about that I probably totally should at some point in one of our future talks. And essentially, the size and parameters of your model and the size of your training data are relatively related, as you might imagine. If you have a very tiny model and you have only a little bit of data, that's trainable. If you have a tiny model and a huge amount of data, the AI might not have a big enough brain to comprehend what it's trying to do. If you have a giant data set and a very small amount of data, it won't learn anything because there's so much action space that it could go into. So roughly you want your data set to be roughly 20 times for optimal training performance your model size, which is an interesting finding in that Chinchilla paper. If you're interested, I would recommend that. Under the hood, all these calculations are running on a GPU. There's a cool Fireship video that I've linked here that talks about how CUDA runs on the GPU in 100 seconds. It's very neat. In artificial intelligence, there's a huge amount of AI type behavior and stuff. And it turns out that there's, in this quote unquote stuff and things, I keep saying word stuff and things. What stuff and things am I talking about? There's a recurrent neural network that's like one of the types of architectures for a machine learning model. Convolutional neural networks is another like architecture for machine learning models. Long short-term memory is another like data structure of like how you can structure a machine learning model to learn in a particular way in order to achieve a certain task. And one of the things that current AI researchers kind of do is they go through each of these different overall types of data structures for AI, and they learn each one in particular and learn what its use cases is and what it's good at and what it's bad at. So for example, earlier we talked about embedding slash vectorization as this first one, and the embedding slash vectorization can be utilized in order to take text and convert it into semantic meaning, where it's like what it actually means. Like I went to the store and I went to get food might be very similar in semantic meaning, but I went to the store and who has tonight's math homework? Very two different semantic meaning sentences. So after you understand like each of these data structures and what inputs and outputs they have and what they utilize on like a lower level, after that you kind of like combine these into like larger data structures. So how many of you guys have seen this photo out of curiosity? This photo right here is called the transformer. In this very, really revolutionary paper, there's called Attention is All You Need, is what the title of the paper is. Google introduced this new crazy model architecture. It's a encoder decoder type architecture. The left is an encoder and the right is a decoder. And inside of each of these things, each of these blocks, there are smaller AI data structures is what I call them. I don't think that's the correct term for it, to be honest. So I have to do some thinking on that, what other people in the industry calls them. But we talked about embedding such vectorization. We can see at the very bottom, there's input embedding and output embedding. So like, that's one that if you know about, oh, that goes right there. You understand what it does. There's another mechanism called attention, where given a sentence, it allows a neural network to pay attention to not just the first word, not just the second word, but given the first word, which of these other words matter in terms of its semantic meaning? Given the fourth word, which of these other words matter in terms of its semantic meaning? And so once you understand and know attention and normalization and feed forward, like each of these pieces, parts individually, you can create these more complex systems that can eventually get these crazy, crazy outputs. So like the idea of a transformer, at the end of the day, all it's supposed to do is predict next token, which a token is kind of like a character of text, kind of. So all it's really doing is it's fancy autocorrect at the end of the day. And it's kind of interesting how uh, given like all of the internet, all of human knowledge, and we cram it into like a 100 gigabyte size file utilizing this transformer architecture, we just, that all it was told to do is predict next token of text. Like we have these emergent phenomena where it turns out that it can actually do a lot of other things outside of predicting next token of text. So like I'm going to do a live demo here, for example. You guys are going to have to try to predict what the next token of text is, okay? I went to the store. Okay, there's another one. How about 2 plus 2 is?
4.
That's good.
It's a perfect example of ChatGPT being wrong.
Yeah, true. But when you said 4, I actually got you to do math, even though it was autocorrect. So I like got you to do something new, and like that was kind of like a more simple example. But it turns out that as you zoom out of like different semantic things that you need, that you might want to do in terms of just predicting next token of text, turns out might be an okay abstraction of learning just about the world and different relationships of words and how they all interact with each other, which is really interesting. But having someone who doesn't know about AI go just dive deep into this transformer paper, it's probably definitely possible, but man, it's going to be rough to dive in deep. There's kind of like a top-down approach and a bottom-down approach to learning AI. And in my opinion, it's the most fun to go from both aspects, where top-down is like, what does the AI do? And like each time you're interested in something, you kind of like peel a layer off the top of like, well, how does this work under the hood? Well, how does this work under the hood? And at the same time, from the bottom up, it's like you start with your very basics. This is a number. Number can be multiplied with other number. Lots of numbers can be multiplied together with other numbers. Turns out if you do it in a certain way, this other phenomena happens. Turns out if you attach those things together, this other thing happens. So eventually they like meet in the middle in terms of needing a really, really good like math background, both a little bit in calculus to like understand and know what's going on, as well as linear algebra is another really, really good basic base knowledge base to have in order to do a bottom-up approach. Now, you have each of these pieces, parts of this giant AI architecture. How are those implemented? You could implement them from scratch yourself in C++ if you wanted to, and we're a slight masochist, but it's possible. Or you can utilize like libraries that other people have already developed to do each of the pieces parts for you. 4 such libraries are Keras, TensorFlow, PyTorch, and scikit-learn. TensorFlow is developed by Google. PyTorch is developed by Facebook, question mark?
It's an independent organization with multiple funding sources.
It's an independent organization with multiple funding sources. Keras is like a wrapper above other systems to where you can kind of identify these layers. So in this multi-layer perceptron dealio I was talking about, where one of these blocks, for example, might be a couple of, sorry, I'm jumping around a lot. One of these blocks, inside of those blocks might be several of these multi-layer perceptrons back to back to back doing matrix multiplication. In order to implement those matrix multiplications, instead of typing out a bajillion equations inside of your C++ code, you can just identify what it is that you want them to look like in terms of Keras. You like have a layer, you have your number of layers, you have the number of quote unquote neurons inside of each layer, because it's kind of like roughly representative of a human brain in terms of how we found it. There's not necessarily evidence that the brain learns using backpropagation, to be honest, but there are definitely lots of like analogs between how our brains work and how this stuff works in the real world. So you use one of these tools in order to piece together a lot of these neural networks. And generative AI, which is what I've mainly been talking about today here, it's like, you know, a form of deep learning where there's a bajillion layers to these large language models, and each of those layers in particular are extremely wide. There is a really, really, really cool PyTorch playground that's on the right here that I strongly recommend just playing with, going over to their website real fast. And we can see here this is 2 neurons connected to 4 neurons connected to 2 neurons. So before I was talking about billions and billions and billions of numbers that can have emergent phenomena. Well, this guy has, what, 4, 5, 6, 7, 8 numbers that end up getting multiplied and added together at the end of the day. And it turns out that you can use it to predict, given, you know, simple data sets, where it needs to slice lines in it in order to learn. So that PyTorch playground, really, really good. So this guy right here, we talked about fine tuning a little bit to get an adaptation on a large language model. So it turns out that there's this thing, you know, called fine tuning or retraining. They're a little bit different, but very related, where you have a large language model, and let's say you want it to act a certain way. Built into it, you might train a LoRa, where this LoRa that's placed on top of it is actually additional neurons that are not in the original model. And you give it new data, and it goes through, and you know it's not what you want it to be, so you take the difference and you apply backpropagation. But you only apply the backpropagation to the new neurons that you added to the system. And that way, you end up like this little neuron adapter. Like imagine you take a chunk of brain and you like kind of attach it to your to your head to like operate in a certain way, if you will. And then that way, they're like hot swappable. So suppose you want it to act in way A, you use LoRa A. You want it to act in way B, you use LoRa B. A con again with LoRa training is that you can't embed new information into the rest of that model because the rest of the model stays the same. So there is limitations here, and that's where you might do a full-on retraining where you retune the actual weights of the model. One of the kind of interesting things is like if you look at the license behind, let's say a company gives you the weights of a model and they give you a license of what you are allowed or not allowed to do with it, and then you do something to change all those weights in the model, technically it's like a whole different set of numbers. So like legally, what do you do? Is it the same model and trained again, or is it just like a whole new model? I'm under the impression that the way that Mistral did their thing is there's this company called Meta, which is what Facebook turned into. And their AI studio produced this open source large language model called Llama 2. Was really popular, but it could only be used for research purposes. I'm under the impression that, and this could be wrong, so I'd recommend fact checking me, but if you take Llama 2 and you do a fine tune, or not a fine,
Yes, fine. It was retraining.
yeah, you do a retraining on it.
Yeah.
Sometimes people say those words interchangeably too. So you kind of like have to look between the lines, see what they were talking about. But they did an actual retraining of all the different weights on Llama 2. That was, you know, a really, really good model that was only used for academic purposes. And therefore, they produced a whole new model file that's not at all similar to the original model, even though one came from the other. And therefore, they can claim, I think, it's a new model, and therefore you can use it for commercial use.
Yeah.
Kind of interesting. So it's like lots of legalese in the AI world today. This is an example of fine tune, which is too small to read. But the TLDR is that if you look at the green in the upper right, there's a little bit of largeness to it. You look at the green in the bottom right, it's a little smaller. So you can use fine tuning to shrink your model output, your not your model output, your prompt input. Okay, where to go to learn more? This right here is one of my favorite slides because you're kind of looking at, also with this entire guy, what I do every day after work, pretty much. So this is like my livelihood of like different places to go to learn things about artificial intelligence. I only could put like so many of them into here, but like one of the really best ones of like going from nothingness to somethingness, in my opinion, is the LLM University by Cohere. Um, they have basically a whole step-by-step of if you want to go underneath the hood and how it works under the hood, and even they go into each of the different chunks inside of our architecture, our AI architectures. They go under the hood in that, all the way up to, here's how you prompt engineer, all the way to like, this is how you actively use it. So they have that whole kind of wide range spectrum there. Really like that one. A minimalistic implementation of GPT-like transformers using only NumPy is a video by this guy named Andrej Karpathy, I think is his name, question mark. But he's one of the like largest YouTube channels where he was one of the original people, I think, that worked with large language models. And he's kind of made these YouTube videos available for free for everyone, implemented in very simple technologies. So that way, the machine learning community as a whole can learn about how these systems actually work. So his resources are really, really good. Another one of my absolute favorite ones when you're talking about like learning how they work underneath the hood is the 3 Blue 1 Browns, the basics of neural networks and the math behind how they learn. 3 Blue 1 Brown, I don't know if you guys have ever seen it, but this is a guy on YouTube who makes these really, really awesome, normally math videos with really good animations. So you can actually see what they're talking about in each of the different sections. And their machine learning slash neural network video series is one of the best that I've ever seen. And in addition to the YouTube videos, alongside it, they have a blog post. And inside the blog post, it's relatively interactive of not just what happened in the YouTube video, but they'll have like little demos to where, remember how I said that you can have the classification between different numbers? You can see this is a 1, this is a 2, this is a 3, this is a 4. You can literally draw the pixels yourself and hit go, and you'll see it go through the matrix multiplication and then circle one of the ones on the outside. So really recommend that course. TensorFlow Playground was the one source a couple slides back that I really like. This guy on the right-hand side here, PyTorch Playground again. Very, very good for learning both about PyTorch and about neural networks as a whole. Because neural networks has a lot of different use cases outside of just deep learning and generative AI. You can identify layers and have a data source and train a model using different mechanisms, right? There's classification where you say the thing is A or B, and there's regression where you have it train on itself, or there's even like generative, which is not one I talked about, but Mario at the very beginning, they had a character Mario try to play a level, and when it died, that was one data point, and they ran that 10,000 times, and they checked to see which of those guys performed the best, and they took those models, and then the rest of them they murdered, and they had these re-propagate out that are very similar. And they all run all those again, take the best off the top, murder the rest, retrain, just cyclical system. Very interesting. Other tools to go, they have AI Explained for YouTube channels. AI Explained, Matt Wolf, Andrej Karpathy, which I mentioned, 2-minute papers are all absolutely fantastic in terms of some of them just keep you up to date with AI news, like AI Explained keeps you up to date with AI news. Same with Matt Wolf, but Andrej Karpathy goes really, really in depth in like how it works. 2-minute papers is just like overarching, like this technology exists and this technology exists, and just imagine what's going to happen 2 more papers down the line from this. And it's really fun to see their video series over time, where like initially, like prior to generative AI, there's this thing called a GAN, or generative adversarial network, which is kind of like the very first like really, really successful image generation AI architecture, and that proliferated for quite a set period of time, and before like things turned into like the transformer era. In today's world, a lot of things are going towards the transformer era, which is kind of an interesting tidbit to see. But I can sense myself talking in circles here, so I think I'm going to go on to the next slide here, and you cannot see any of these, but if you
Whoops.
but if you get the slides, here's just basically a list of like podcasts that I would really recommend if you want to just listen to really smart people who know way more about AI than I ever will. Like it's so cool to just to listen to these people and just absorb information from them. Papers to read. Um, Here's a giant list of different little smaller AI for pretty much for every single one of those AI architectures I talked about. What it was is it's a group of researchers that wanted to try something and they tried it and they documented how well it worked in a research paper and they publish it. And then other people see that research paper and then they'll either retry it or try it with different modifications and then publish their findings. And this is like a collection of some of the ones that actually led up to the GPT slash the transformer. So you have Laura's there, which is like one of the ones that after the fact. It'd be interesting to put these in order of like them releasing. But I don't know if it's best to learn it in order of them releasing, or just like pick one that you think is interesting and learn about it, and then pick another one you think is interesting and learn about it. It's kind of like if you're learning programming, like opening a C++ textbook and like reading it from front to back is like really, really hard. But instead, if you have a project that you want to do, you dive into the project and you just learn the parts where you need, right? So that's why I think just one of the ones, for example, is efficient estimation of world representations in vector space, which is so cool that I have it on there twice, I realize. Is amazing because it's kind of one of the things that turns words that you and I speak. Computers don't speak in words. Computers speak in ones and zeros and numbers. So it takes words and organizes them in ones and zeros in semantic meaning, which has a lot of there's a lot behind that, and it's very cool. Sequence learning with neural networks was a precursor to transformer model architecture. Large language models are unsupervised multitask learners. Like there's a lot of papers out there that just utilize, for example, GPTs in ways you might not expect, or transformers in ways you might not expect, and get interesting results out of it, and then just like share their findings. So it's just interesting to pick up a paper and get its output. At the beginning of each of these papers, it's an abstract. So if you double click on one of these, just read the abstract and be like, is this interesting? Then you can read more. If it's not interesting, then you can either throw it away, or if it's interesting, then you just go to YouTube and be like, this paper explained to me. That's very helpful. Also, because we have ChatGPT, unlike the people who came before us, before 2 years ago, we can take anything that we don't understand in these papers and just copy and paste it in a ChatGPT and be like, explain this to me. Then it'll explain it to you, and then it'll be like, explain to me like I'm 5. Then it'll explain to you like you're 5. It's great. So, yeah. Every time I've talked to people about AI, the third question or fourth question they almost always ask me is about ethics or legality, which is an absolutely great thing to talk about in my opinion, because
We're gonna have a talk just about ethics.
yeah, there's a lot to cover. So I'll give like a brief overview on what I know about AI, ethics that I've read about. So one of the things, for example, in the AI art community, there's people on pros and there are people on the side that AI art should exist, and there's people on the side that AI art shouldn't exist, and everyone in between. One of the things that's pretty much has been agreed on at the current time is that we can't use other people's likenesses. So for example, if you're the Beatles, right? I can't just make a song by saying, I want a song like this, but the Beatles, because you're using someone else's likeness. Or let's say you have an artist that you really, really like. You can't say, I want a image of a camera in the style of so-and-so, because you're using their likeness. Also, if I were to take a 10-second clip of you and then use it to robocall your grandmother and say that, please help, I'm stuck, I need like money because I'm like in jail and I need bail, please send it to this Venmo address so I can get out. That's me using you in your likeness. So that's legal. Cannot do that.
That's legal for many other things, but that's part of the legality of it. Yeah.
Yes. So, yeah, these AI systems are not like releasing whether or not they use the training data, which training data they use. They might be trained on copywritten information. But also, like I said, you have 20 times the training data as your model size. So your model size cannot possibly contain the training data. Instead, you can like learn stuff about it. And like an artist, when it enters the world, it learns stuff very similar to like kind of these GPTs do. They don't learn in similar way in the mechanism that they use to learn is different, but like conceptually it's somewhat similar. So it's like, is that allowed or is that not allowed? Because they basically are being directly trained on these copywritten works, but also that's what humans do. But also, it's fuzzy, right? So lots of talks about that. It has been ruled that AI cannot legally own things itself because an AI is not an entity or human or individual. So a human who uses an AI can do stuff. So if like this AI can be used for evil, yes, but it's also the human using the AI for evil. At least in the current iteration, let's say you make an agent and the agent goes off and does its own thing, then it's still the responsibility of the person that or entity that created it. So hallucinations. There is this one really interesting story about a person at Delta Airlines who, I think it was Delta Airlines, who this guy went on, I think, a bereavement trip. He went like across the world and to a funeral of some sort, and then flew all the way back. Very sad situation. And he went online to the Delta Airlines like chatbot, and he realized that the chatbot is a large language model. And he basically like said, you know, I was there for bereavement, like guilt tripped it, and the LLM was like, oh my gosh, you're so right. That's so sad. Uh, and he was like, well, you should like let me only have to fly for the price of $1. And the LLM's like, you're right. We should just give this to you for $1. And because that the LLM was on Delta Airlines website and was talking as a representative, I guess it ended up being brought to court. And the court basically ruled, yeah, you have to uphold that because you guys said it. So if you just have your large language model systems like going into the ether and saying things on behalf of your company, turns out you might be held liable for the things that your company says, even if it's AI generated, which makes sense, but also can be dangerous for AI uses, right? So there's data concerns with sending up your data. There was this thing with Gemini when it came out. Gemini created a bunch of images as one of the things it can do. Right? It's multimodal to create text and create images. What turns out, like if you asked for, let's say like a Nazi, like for historical purposes, it would give you a black Nazi. And you ask, no, a Nazi, and it'll give you uh, a Chinese Nazi, and like not like historically accurate depictions. And it turned out the reason was is because they were doing prompt injection behind under the hood to try to make it more culturally diverse. And I think that their biggest problem in my mind is that they didn't tell people they were doing it, and they actively told people that they weren't doing it. But based on how the AI performed, it was very clear that it was performing that way. And so they shut it down. They did some internal changes, and now when you ask it for historically relevant context, it does its best to provide the historically relevant context and does not, I don't know what the correct phrase is there, but does not, you get what I'm saying.
We're at -2 minutes.
Yeah, I think. Yeah, if we're at -2 minutes, the future is hard to predict is what I'll say about this slide. I have lots of thoughts. We should talk about them sometime. And here's a QR code survey that I would really, really love for you guys to fill out because this will tell me what it is that you enjoyed about the talk, how I can be better in the future. Also for future talks, if we should go in depth on one of these topics in particular. It can be anything from maximizing the effectiveness of ChatGPT prompts to integrating ChatGPT into like a product, or running your own large language models, or doing your own training, creating images. What are you guys interested in? That is the question. So you guys could fill out this QR code survey. That would be absolutely awesome. So while I have this on the screen, so if you guys want to, you guys can go to this QR code. I want to ask more questions. Do any of you guys have questions for me given everything I've talked about?
Yeah.
Did you put this slide deck together, or did you have AI generated for you?
There was a lot of ChatGPT, but for the most part, we did it. Actually, Kyle did it, and I just kind of helped.
Good job.
So there was a few AI generated phrasings, a few AI generated images, but yeah, humans for the most part. Any other questions? Yeah. Yes. Yeah, we're gonna post them on this week's event page. So we'll just post a link at the bottom of the page. On Meetup, yes. So yeah, the slides will be available. You were talking about how you wanted it in a high school context. 3 blue, 1 brown. Was that right?
Hmm?
I didn't dyslexia that. All right.
Thanks.
So that is the best resource in my opinion because he teaches it in a way as long as they have, I would say a high school level math, like probably a junior or a senior, they do a really good job at explaining it. Yeah. So we recorded this lecture. We're going to put it on YouTube. So we'll have both available. Any other questions, comments, concerns? Yeah,
I also want to check out StatQuest.
StatQuest.
It has like a similar format as Three Blue, One Brown, um, but its focus is more on the AI and the mathematics behind it. Three Blue, One Brown.
Yeah, he's more of a math guy at the end of the day.
StatQuest is very good.
Okay.
He also uses like imagery to convey the points and drawings. I think he gets a little bit more into the, if you want to say, the smaller part, like looking at how it works from a smaller standpoint and then build out a little bit. But he doesn't go as big as Three Blue, One Brown. And then the other one I say is Steve Brunton. I think he's a professor over there at Washington State out there in Seattle. He deals more with the physics side of AI, physics inspired AI. But he's got a good book. It's on dynamical systems. It's a little more advanced, of course, against the math side, but its focus is more on the application of physics to designing AI systems.
We'll definitely have to look into that, especially Kyle who loves that kind of stuff. Any other questions? Yeah. We're going to look at the survey results as well, but we already had a few ideas in our head for what we were going to cover. One of the things we discussed is we wanted to do a more practical lecture where we actually have the audience participate and like actually show how to do something like either with Python or even just within ChatGPT itself. Prompt engineering was a big skill we wanted to help teach because that's going to be a big deal. It is a big deal now and it will be in the future, we believe. For the next meeting, I think yes, it would. Anything else?
I have a question. That's me asking you guys a question, I guess. The way this room currently is oriented is in a classroom structure, so kind of like incentivizes just me to mainly talk and for you guys not to talk, question mark. And I think like one of the thoughts I had maybe is like doing more of an ovular shaped rooms where it's more cohesive, and instead of just me presenting my findings, it can be like each of us talking to each other like through a discussion as well as like a possible format of the future that I think might be really good. So I'd like to have your guys' thoughts on that. Does anyone want to speak out loud, question mark, in front of the class?
Well, what's the level of knowledge that like the general population of this room has about the topic you're talking about?
Yeah, that's so true. I think one of the best things that we can do probably is like when people join, you can say like 30 seconds about yourself and like what it is that you work on, what it is that you know about, and like have it be more of a cohesive thing. So maybe like we can have two different types of lectures, right? We can have the actual lecture where we're giving a presentation, and we can have like the meetup where it's like it's mainly about the humans and individuals and what we know about. So I think that's a great point. Because then we can know what people here do know about and what they don't know about.
It sounds like you know quite a bit about the mathematics behind it, where the overwhelming majority of people, with the exception of if you have a background with biomathematics, physics, or something like that, aren't really going to get, like when you start talking about mathematical architecture like that. You know what I'm saying? Just in that sense, so people's eyes are kind of glazed over.
Absolutely.
If you think about it in the context of like the application of ChatGPT, I think more of a format where it's about how can you actually use this in comparison to like engineering or math, people will start throwing around different stuff that we found creative. I think the outward platforms that people might like, you know what I'm saying, even things that they design, why you designed it, how you thought about it. Because prompt engineering, from what I'm saying, is pretty, that in itself is pretty deep, even without the math side, just about how to communicate with this thing. You know,
Yeah, it's actually more about almost it bleeds into psychology even because it's based on human data. So what tricks you could use on a person, as bad as it sounds, would also work on ChatGPT in a lot of cases.
could you social engineer ChatGPT?
You can. It's been done.
Yeah, but that's what I'm saying. Like most people, we tend to think of like hacking. The biggest thing with hacking isn't really the computer as much as picking problems in the chair, not in the computer. So it's more social engineer. How will we social engineer this thing? I don't think that's necessarily covered as much as it probably should be, because if it's trained on human data, you know, I'm pretty sure it starts to kind of learn those types of things. How could you even in chat GPT or those large language models to social engineer the person that's talking to it?
In that leads into the ethics conversation we had earlier. There do exist. Apparently, they found on the darknet a large language model that was fine-tuned specifically to social engineer people, and it can be used for malicious purposes, and it cannot be understated. That's why a lot of people early on were talking about morality, and that AI needs to be taught how to be a good person, because otherwise you get scenarios with that where you have an AI now that knows how to hack a computer, knows how to social engineer their way out of a problem.
Yeah, one of the other interesting things is like when normally these GPT models are created, they're in a completion format where it's like it just predicts next token. There's actually a transformation step to get it from a completions model to what's called an instruct model, where you can give it a like a chat and it is told at the very beginning to act as like a helpful assistant, and then it helps you after the fact. And the thing that bridges that gap is called reinforcement learning with human feedback, which is another excellent paper that I recommend reading. It's very cool. And basically in that step there is where you kind of like tell it how it should or shouldn't behave. So if it says something where it tries to social engineer, they go bad AI. And when it does something good, then you go, yeah, that one looks good. And this is how you can improve.
It's a question for both of you, so you guys can answer it.
Swap the microphone back and forth. Yeah. Next time we'll have two.
So in your journey so far, like what are the biggest like aha moments or something that like something that you encountered, and what was your experience?
For me, it almost feels like more of a slow burn where I just slowly get better over time, especially with prompt engineering. Um, it requires a lot of practice, but we're hoping that with this talk, we're able to condense that down so other people can learn it much, much, much faster. As well as like, there's a lot of conceptual things that I even today still struggle with. Like for example, I said earlier, I don't know if I said it out loud, but I thought Kyle is more better with like he said the mathematics, the more theory. That's much more what Kyle's better with. I'm more on the practical side. Like if we need an AI hosted, that's what Chandler does. If we need a RAG built, that's what Chandler builds. Well, Kyle can give the theory, give amazing lectures on theory all day. So, but yeah, it's mostly just practice, 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 just like programming. It's no different in my opinion. Prompt engineering is programming. So here's Kyle.
Yeah, to go back to the question of like what I think was some of my aha moments and like how I overcame them. One of the biggest things is AI is a broad term and I didn't know it existed. So this lecture is kind of the lecture I kind of wish was given to me so I can know what things exist. Because at the end of the day, people are trying to use AI to solve problems. And by knowing what exists, you can use that to map over to here's my identified use case and how I can like implement that to actually get real world performance out of stuff. Because people, when you bring, if you get a collective of people and just ask, can AI do this? The answer right now is probably pretty much, oh yeah, I can do it. It's like, how? And so that takes a lot of steps then. So a couple big aha moments. Getting ChatGPT to explain me things I don't know or understand. Having good fundamentals in mathematics has really helped me understand a lot of what happens underneath the hood and attacking it at multiple levels. All three, in my opinion, top down, bottom up, and also the topics I'm particularly interested in. I think also Chandler and I have had a couple use cases where we wanted to build our own AI systems, even just to learn how it works under the hood, and being willing to dive in and deep, like we mentioned, SearchBase is one of the tools that does retrieval augmented generation that Chat with RTX does natively out of the box. But we were able to build the system that anyone can download and utilize.
Chat with RTX didn't exist at the time though, but similar tools did.
Do you have a project that you're currently working on?
We have many. We have too many, in my opinion. Can I take them? So our main focus right now is building out mostly internal tooling for us for helping us ourselves out. But a few of the big tools that we've built that I'm proud of. One is called AthenaDB. It is a vector database system that I built that is serverless, so it runs entirely in the cloud. It is I think it's $5 a month is the starting hosting cost because you have to pay for like a subscription through Cloudflare, but it's an infinitely scalable vector database where it will automatically scale with your business. So it can handle up to millions of queries per second. And when it's not running, it costs you $5 a month. Of course, you do have to pay for the additional usage, but we've also built Aurora, which is a Discord-powered chatbot using ChatGPT under the hood. That was more of a project so we can learn how the new Assistance API within ChatGPT works. We've built AutoDocs, which is a developer tool that allows you to generate code and generate files entirely locally, as well as have an in-terminal ChatGPT prompt style chat. And then finally, we built SearchBase, which is a RAG program that can be hosted. And then it also has authentication built in, where you can have just your users log in, they can upload their own files, and the files can be analyzed and shared.
And then we also often build even smaller tools that then get integrated into some of our other tools. So one of which you saw a couple slides ago is the memes. I made a meme generator. It's really fun. So in AthenaDB, or not in AthenaDB, in Aurora, which is a Discord chat, you can have do/meme, and it'll generate a meme for you given a topic, and say, give me a meme about AI. And we got what you saw right there. You can say, give me a meme about cars, and I'll give you a meme about cars. Give me a meme about, insert topic here. And it goes. And part of me wonders if I should just like hook it up to like a ChatGPT ideation feed, because I actually do this for myself. I have this automation that runs every morning at 8 a.m. where the meme generator generates 10 fresh memes off the presses for me. And
It gets annoying because it's in a shared channel with the two of us.
But it's great.
Maybe two. So we get 2 good memes a day. We get 2 memes a day are adequate. And then what I need to do is write a bot that rates them and automatically post them to my Twitter. That's what I need to do.
Absolutely. I had another one, but I forget now. I laughed too much.
This is, I don't know how ignorant or what is going to come out of it, but I know what prompt engineering is. But knowing what AI can do, why can't AI actually produce or not produce, but kind of read between the lines of what you really want instead of really, producing prompt engineer or requiring prompt engineering to understand what you're really up to. In other words, if we can do like one of your slides, they had like a chip in his mind so that they can read his eyes or whatever. Why can't AI produce through so many iteration of understanding what someone really wants to say, wants to do, or needs to do, and do?
There exist tools that exist. We built one. It's called Prompt Smithy. It was another one of those weekend fun. We wanted to do it, see if we could do it projects. Basically, what it does is that you give it a basic task, like write me an email to respond to a disgruntled customer, is one of the examples that I used. And then it would write you a very, very detailed prompt that convinces ChatGPT or Claude or whatever else to do it reliably. It can do that. The problem, it starts to break down because humans don't know what they want.
Right.
So it breaks down because you need a lot of iterations no matter what. You need a human in the loop to know what a human wants to do. So yes, we can build tools that will help us accelerate the process of prompt engineering, such as Prompt Smithy. A few others exist, I know for a fact. Do you know off the top of your head?
The mechanism behind how it works too is called a meta prompt, where basically someone sat down and wrote a giant prompt to read in between the lines.
Yeah, and my thinking is the more data it collects from prompt engineers, the more it can actually predict what the person wants to say and kind of give it.
In theory, that is possible, but the human still is going to need to know what they want. And a lot of times it's going to still take a few iterations to get there.
Yeah, one thing I think is understated is like if let's say you're in a situation where you're a software development studio and you meet with a client and you discuss what you want, and then you go behind the scenes and you build it over the course of normally several weeks. And you meet together and it's like, oh, it turns out the client didn't know what they wanted. But I think part of the issue there is not just that the client doesn't know what they want, but it's that the feedback loop is so long. You have weeks there, where now with these new AI tools, like you say what you want because you think you know what you want, and then you see what you got, and you're like, oh no, actually I want this thing. So by having these recursive systems with humans in the loop, I think it gets more efficient over time.
Yeah, the feedback loop, instead of being weeks, becomes minutes, which makes it much quicker.
Thank you.
Any other questions? Comments, concerns? Do you want to do the last slide real quick? So if anyone wants to contact us to either talk about AI, we offer a few AI services that we can do, help you set up any of the products we've developed. Feel free to contact us. We also have business cards at the table at the exit. So there's our email, our Twitter, and our website, and then this QR code will take you to a contact us form where you can fill it out and we will get back to you within a business day. I think with that, that wraps up our talk today.
I think you guys will do a great job with this topic. So looking forward to
Thank you.
Thank you.
Which, by the way, anyone feel free to stay back and talk to us individually if they would like.
Yeah, I think one of the issues with the classroom setup is now everyone is like incentivized not to talk to each other and leave quietly like we did in school. This is one of the problems about this. So